is this guy wasting my time like on a Friday morning, right? So that's me. And a little bit about myself. I started life as a baby physicist at USP São Carlos, go CAASO. And towards the end of the course, I realized that I didn't really want to become a college teacher. So I dropped out in my last year and founded EHPC, which in retrospect has kind of like the worst name for a tech company. It's like more boring than IBM. But it worked out pretty well. It was eventually sold to a company in the US where I went to serve as the CTO, the majority. It was a NAND company. And most recently, I've moved to AutoScout 24 in Munich. And the AutoScout sells, it's like a web motors-like platform. It sells cars online. And quite interesting, it comes full circle for me because I'm finally joining the family business of selling cars. But instead of doing that, you know, like with charisma and empathy and human warmth, I use the cloud. Yeah. So I came here today to talk with you guys about real-time data activation, analytics, intelligence, and decision-making. But I'm not going to do that, actually. And the reason why I'm not going to do that is, as I was reviewing my presentation on the flight here, I quite literally bored myself to death. And the couple next to me actually thanked me after I whipped up my MacBook because it got their child to sleep. And yeah, and then I thought, like, I'm gonna do something a little bit different. So instead, today I'm gonna take you guys into a fantastic and fun adventure towards big-ish data activation with small teams and a bunch of disclaimers. So now you guys are probably wondering, like, why? For instance, I know that Fabio is wondering, why did I invite this crazy person to present here and change all the presentation literally 24 hours before? And the reason for that is a little bit over half of my career at this point has been spent with creating organizations, creating teams that get this thing done, that get shit done. And before, my presentation was based on the technical aspects of activating data, creating a data pipeline, creating a data architecture, and that's all well and good. But that's not how most of you are going to approach this problem. And come Monday, if you guys have a similar problem, what will happen is that you have to make this happen with the resources at your disposal. You have to make this happen with the time frames that you have, with the number of people that you have. If you are in a bigger organization, in a big enterprise organization, you have like many barriers internally that you need to overcome in order to get this done. So instead, I wanted to approach it through that vector. So I basically did this presentation yesterday with no sleep, because, you know, kid cry on the flight. So do not expect the Peter Jackson-like production values from Fabio Akita's presentation, who got him to actually sponsor his presentation. And that's kind of why it looks like the Lord of the Rings. So this pretty much looks like a homework delivered last day of college. And I know that many of you have done that, if not all of you. So without further ado, let's get the show on the road. Now, what I'm going to do here is I want to approach a few cases, a few problems that you guys have faced, are facing, or will likely face in the companies that you work today. And you will have to solve those problems. You have to solve those problems using the knowledge that you have and using the knowledge that you can reasonably get in the not so distant future. And you have to deliver those features to your users. okay? So this is not going to be an all-encompassing, super high technical grade presentation on how to do some of those things. This is going to be focused on the practical aspects, okay? In my previous presentation, I also had lots of code to show you guys. I took that off because I figure like you guys work with code every day, and seeing code here would be the equivalent of like working at Playboy and coming home to a really hot white. Oh wait, that actually sounds pretty good. Anyway, so for first stage, the flood of data. Essentially, you have your application or you have your system within your enterprise, and it's picking up, and you're generating data, and you need to capture that. You need to get that from where it originates to somewhere that you can actually start using it. And I've presented a few possible scenarios here for you guys. So maybe you have a microservice that is pumping out logs or is pumping out data. Maybe you have some background worker that is crunching some data from your database and pushing it, needs to push that somewhere. Maybe if you're like feeling hipster, like you have a sensor doing like an IoT application, and you need to get this data somewhere. Or maybe you have like a device, a mobile device that you're actually capturing this, and you need this to go somewhere so that you can use it. So essentially, you'll be able to push this guy into a data pipeline. Again, not going to go into the details there, but the common candidates there are your FluentDs, Kafka. Those two logos there, for those who don't know, are AWS Kinesis Firehose and Kinesis Streams. And I would like to bring your attention, guys, to the glaring absence in this presentation of anything to do with Hadoop, like HDFS, anyway, any of that stuff, because I feel that if you are in a startup or if you are in a small team in a company and you need to get shit done, you are like nowhere near. You shouldn't, don't even look. Don't even look at anything that is in that echo space right now, because it's huge. It does work. Don't get me wrong. It works. It's great technology, but it was built by a team of like 60 people in a company of thousands of engineers, and that's the reality that they had in mind. And that's not your reality. Like even if you're in Google today or a big company, companies today are being created around small teams, self-contained teams that can own their outcomes. So that is your reality, and if it is not your reality, you should definitely strive for that. So I chose here some systems that are either relatively easy to deploy and manage, or that are hosted. And that's what I'm going with. So the first problem you need to solve here, the first barrier you need to break, is this flood of data. Essentially, being able to capture this data in a meaningful way with the scale that you are trying to tackle, and in a way that works with your applications, right? If you're using Scala, Ruby, Elixir, whatever, in your front end, you need to be able to work with that in a reasonable way. Cool? All right. So second stage, so you got all this data, great. You're getting like hundreds of gigs of data, 10 gigs of data, terabytes of data per day, per minute, per second, depending on the application. And this needs to go somewhere. Likely, you can't push that into a database. You can't push that into a single computer. You can't push that into a flat file somewhere. So what ends up happening is that you need to be able to capture this data, to capture this information in a way that you can either use it right away or store it for use later, or further process it down in order to solve a particular problem. So for instance, here you have your data pipeline, again, pushing data into what people call the data lake, or the data ocean, or the data tank, or whatever data. And it's really just a fancy name for get all of your data stored in a single place, in a way that is cheap, a place that is cheap, in a place that is relatively easy to use with other components, and in a way that you can query it reasonably well to build data representations that can help you solve your particular problems. So two other common ways that you're going to see, or that you have seen already in your applications to get data into your data lake, are going to be your data pumps. So those are your ad hoc scripts to copy data from your databases. Those are your specialized systems that are going to trail database logs and push them into our data lake, and so on and so forth. And another way is, of course, is doing manual ingestion. So let's say you have a customer. This customer maybe is not super sophisticated, and they want to give you a huge data dump of their database or their logs so that you can figure it out. You can do something with it. You can extract some value from it. And that's also something that you need to deal with. So all this ends up in your data lake. Now, more often than not, the data lake is not really the best representation for you to work with this data. It's very messy. It's very generic. It's very there's lots of stuff that you don't need all the time. Lots of dimensions, lots of fields, lots of information that you may not need to solve a particular problem. So don't really want to use that all the time. So what do? You're going to build a data mart. That's one way of solving the problem. And a data mart is essentially a purpose-built representation of a particular data set for a particular purpose. So maybe you're doing aggregations by GPS positioning, and you just really want to know like how many people were in a particular region during a particular time. And you don't need to know like all those other 50, 60 fields that you might have in your data sets there. So you're gonna use a data mart builder. Common solutions are going to be Spark or Hive, or those guys running on, say, EMR or Hadoop, but don't really use Hadoop again. None of the Hadoop stuff. Cubo are also great hosted platforms to do this. Or maybe, just a script. Sometimes, believe me or not, just writing a good script that is running on an EC2 machine can build that data mart for you. But the point is, if you build the data representation that you need to solve a particular problem, you're good to go. And of course, sometimes you need this data faster. You need this data mart maybe every second, maybe every 30 seconds, maybe every 5 minutes. So the technologies from the data pipeline that you choose in the previous stage need to be able to support pushing data or getting data pulled from directly to the data mart builders. So that, as you guys will see further down the presentation, you can use this data really, really fast. Cool. All right. The Lambda architecture. So it's quite interesting because in software engineering, we tend to think that something is really, 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 really hard if it has a paper. And if that paper comes from the likes of Google, then then it's basically the gospel. It's like basically the Bible. And that's not really the case. Some of you who are more familiar with the theoretical rigors of the Lambda architecture might cringe a little bit, but essentially, Lambda architecture looks like this. And it's really just a fancy name of saying, I need knowledge from this data really, really, really fast. So I'm going to process it in a lo-fi way with like low resolution. And in parallel, I'm gonna be storing this data and processing it like slowly, but with much higher resolution, so that as time goes by, the higher resolution versions will replace your lo-fi versions that you had before. So a very common use case that you will need or have needed to solve in your company is probably real-time analytics, right? Like people want nice charts on your pages. People want reports faster than an overnight job. And people want them like yesterday, right? So a really cool solution to solve that problem, if you face it, it's a system called Druid. Druid is a tool built by MetaMarkets. It's a big marketing company from the US. It's an ad tech company. And it really is essentially an off-the-shelf solution to implement the Lambda architecture. The way it works is it provides you with a really nice HTTP API that you can query from your applications to get real-time analytics based on any dimension that you want, any facet that you want. You can break down your data, you can aggregate your data, sum it up, divide, create KPIs that are not present in your data. Say like, hey, I want to create a total price function that is going to sum all line items in all orders in my database. Boom, it's there. And it really usually answers within 1 second or less. So it's really fucking fast. And the way that and the cool thing about it is that if you connect it to a data pipeline like Kafka or Fluentd, you get this information really fast, and automatically you get this information really well after you run the batch jobs. So the way that works is, I'll give you guys the example for Druid here. You have a component called Tranquility. So Tranquility is a Druid component that you can set up and install, and you can push data to it in real time, like really real time. Well, soft real time. It works with a 30-second window. So if you get delays in your data pipeline, which do happen, unfortunately, quite commonly, during these events will be dropped from this particular window. But that's okay, because after they arrive in your data lake, and they get processed by another Druid component that pulls this via batches, using, for instance, EMR, AWS EMR, it automatically rewrites your analytics data in a way that is completely transparent to your client. So anyone connecting to Druid at the other end of the pipeline will basically just see like analytics, and those analytics will improve over time. Druid is a somewhat complex piece of machinery, so I was a little bit wary of including it in this presentation, but at the end of the day, it solves a problem that is so common and so big that I think that it's totally worth the cost. And I highly recommend you guys look into it. If you guys don't want to look into Druid, of course, there is the likes of Spark. Spark has a great streaming solutions called Spark Streaming. That you can use pretty much the same effect, although you do have to write the code yourself. So there's great tutorials online, and it's relatively easy to use once you get the hang of it. Cool? But once again, the purpose here is to build this with a small team. If you do not need to write this again from scratch, don't do it. Just use Druid. Just use an off-the-shelf solution. Cool? All right. Another very common use case that you might see, especially as a startup, is growing up a little bit, and you start to get more sales guys or product guys and essentially business-oriented people in your company. Or if you are in a big enterprise, you just created a proof of concept. It's a really nice piece of technology. It's ramping up, and people want to know more about it. Or maybe like you, your colleagues too. We just had a great presenter here talk about A/B tests. That's also a very good use of the data that you guys can consume yourselves. So how do you extract business intelligence from your data in a way that doesn't suck, in a way that it doesn't use like some huge enterprise offering that will be a pain to install and will require 50 people, even though you paid a fortune for it. And believe me, those exist. And I used one of them today, and it sucks. A very good way of doing that is you can if you're in a hosted platform, as you should, having small teams today. If you're in Amazon or Google, you have great systems that you can use to extract data from your data mart and move it from your data lakes and move it into data marts that you can then connect very popular BI tools to. And extract like great knowledge from it. If you guys are not familiar with, you have Tableau. It's one of the top companies in the world in terms of data visualization. It's really, really, truly amazing. Looker, it's a new contender. It's closer to the data side of things, but it's still very, very, very cool. Imply, it's super, super new. They're actually from the core group that created Druid. And they basically added a bunch of cool stuff on top of Druid to do BI. So you can run queries in Imply to get business intelligence out of your data store, and it takes seconds to run. Whereas if you run your plain old data job or materialized view or whatever you currently have running on top of Postgres or Oracle, it's not going to be in seconds, I can guarantee you. And there are basically two ways that you can interact, that you can get a BI tool to interact with your data. One of those ways is you use a tool like Spark or really Hive, any of those guys, to create a data mart, to create a representation in another system that you can connect your BI tool. So for instance, Amazon Redshift is a pretty popular choice where you can essentially store data that you're extracting and pre-digesting from your data mart, and then you can connect Tableau to or Looker to directly. That is a very interesting solution, although it does basically duplicate a lot of your data, and if you're working at scale, money becomes the problem. So you need to be very, very careful about going to this route. Another route that has become more popular as of late is connecting your BI tools directly to your data lake, and that is really that is somewhat groundbreaking to some of these companies. I know, for instance, that Tableau just released connectors to systems that allow you to query your data directly. And that's actually pretty cool because it makes your architecture even simpler. So a bunch of query engines that you can use to connect your Tableaus, your Lookers, or your implies directly to your data are, for instance, Druid itself. Druid's pretty cool because it can actually pull data from your data lake too using the batch jobs, and it works pretty fast in that sense. And after that, you can essentially just connect your BI tools to it. Facebook Presto is a relatively recent contender that was created by Facebook, so that's pretty solid software right there. And it allows you to query with a SQL-like language data that is in JSON format, like new line separated JSON logs. Very, very common out there. And of course, all of this stuff can run on top of Amazon EMR, or you can use Google's BigQuery or any other of those hosted services to completely cut out the data mart out of the equation. If you guys have faced this problem or expect to face this problem already in your companies of having to give these figures or use these figures within your teams yourselves, I highly recommend taking a look at those tools. Because the more you can dry up and shorten your data pipelines and your stacks, the best is going to work to your advantage. Cool? And well, AI, right? That's something super, super hot right now. I think that we are in a pretty cool point at our industries because we are used to pushing our applications, essentially to provide input to our applications and getting really, really simple feedback. But we are in an era where our applications are actually able to push back, to provide way richer information back to us. Assistants are a very relatively simple use case of this, but really you have like your chatbots, you have your systems that you don't even see that are collating data and understanding data within companies to provide you an experience that you have quickly grown to become accustomed to. Like, if you guys use the autoplay feature from Spotify, that's pretty much what's going on behind the scenes, and it's pretty awesome. So how do you do that? How do you get data that is boring, static, and blah, and turn it into like something that you can actually use? Well, I'm going to show you guys a very particular use case. AI is a huge field, and I don't think I could cover everything here within the 18 minutes and 55 seconds that I have at my disposal. But one particular use case that I can cover is the use of models. So if you guys have a web application and you need to do some quick responses to your users, kind of like a chatbot, or if you have to do fraud detection, like you don't want people using your API without in ways, your public APIs in ways that they really shouldn't, or you want to provide a component within your architecture that can be used to provide an intelligent behavior to the user by collating responses from other components, then you're gonna deal with a model. So a model is essentially a piece of code or a piece of functionality that you can use to classify or predict behavior. So classical example is a neural network where you train your neural network upon a bunch of data, and then you can use it to predict if a particular document matches another particular document, and by how much. Another very classic use case is your Bayes filter for doing spam detection or fraud detection. Cool. Now, how do you do this at scale with a small team in a way that doesn't really suck? So a very interesting way of solving this problem is using any one of those logos that I put down there, but in particular I'm going to talk about H2O. H2O is a relatively new project that gives you a bunch of tools that help you really connect to your data relatively easy, define the type of problem that you want to solve, and it spits out a piece of code that you can either use it within your applications, or more recently, self-host and start using a standard HTTP API right away. So for instance, here you can get data from your data pipeline, say during stream processing. You can get data directly from your data lake, depending on what you're trying to do. You can get data from your data marts, again, depending on what you're trying to do, and push it through a system like H2O, which really is running like Spark behind the scenes, and spit out like a linear regression model or a support vector machine. And that allows you to do like a whole bunch of cool stuff, like classify users, connect users together, connect users and products together. And this piece of code, you can either load into your application. So for instance, you can wrap that around as a library in your applications. It's a piece of Java or a Scala code. Or you can load that up into a platform that it provides to you that automatically gives you an HTTP API for free that you can start using from your microservices. If you guys are building anything that requires any meaningful scale, and that you can't just use like a small Python script, this is the guy to look. Cool. All right, so after all of this, what do we have? So we are able to solve some really basic but interesting problems while working with data at scale. We are able to capture data. We are able to activate data real time, soft real time, and batch. We are able to give analytics to our users, and we are able to provide business intelligence to our stakeholders, to our colleagues, and to ourselves. So if you think about it, you would have to grow a lot as a company or as a product before you need anything other than that. Of course, some of you are working on like really amazing stuff that is really cutting edge, but if you're, chances are that if you're solving a problem in a startup, like any normal application, if you're working within an enterprise and you need to provide any relatively normal piece of functionality, those are the main problems that you're going to run. Cool? So essentially, just what I said, you're able to capture lots of data, you're able to store lots of data, understand lots of data, activate lots of data, make a lot of money, and of course look cool talking about data. Case in point. Now a few disclaimers to you before I wrap this up. Working with data is probably one of the most important things we're going to do at our companies today. Just like Fabio was saying, the UI problem for web has been solved. Like most of the basic problems for web applications or even mobile applications have been solved. The next step, the next point in the evolution of our industry lies into looking at the data, understanding what it means, and extracting value from it. That is more important than routed corners. That is more important than providing like just yet another simple search functionality to our application, or like just like crappy copy of a hosted service that you could get either for free or for a very low value. So first of all, execution beats technical rigor every time. I'm not saying that you should do like a shitty product. I'm not saying that you shouldn't think about what you're doing before you do it. And I'm not saying that you should essentially just wing it. But when you're working with data, it's very, very, very easy to slip into, hey, let's talk about this paper, or let's talk about this new thing that just came up. Like, you don't need to work at the absolute cutting edge, the bleeding edge. Just get it done. Getting something done today in this space is far more important than doing the absolute best and being 20% faster because you're using some other library that just came up. Just get it done. Second point, execution beats using all those shiny toys. So I've developed a rule. When you build your data architecture, try to use at most 5 logos. So there is so much stuff out there, so much tooling that you can use, so much stuff that you can that is very, very exciting to use. Don't get me wrong. Like there's stuff coming up all the time. People are super excited about this, and it's very cool to work with these things. But first, it's very, very easy to start getting to the mindset of, oh, let's use the right tool for the job. And that sounds great until you see that you have like 32 tools to do the best job that they can. And now you have to have people that know 32 tools. And you guys think I kid? I've seen companies that actually have 32 logos on their data architecture. And it sucks. Second, there are many things that you're going to see when you're building your own data architecture and solving it. There are many logos that can do more than one thing. As I just showed you, like Spark can do like a lot of that stuff, both on the streaming processing, on the batch processing. It works. It is the basis for H2O's sparkling water system. It's essentially a very flexible system. So it's a tool that you can use to solve a lot of other problems. Yeah, maybe there's like something else that can do something that Spark does much better for that particular use case. But Spark solves a whole lot of problems. Same thing with Druid. Like Druid can do analytics, Druid can do BI. And that's one thing that you had to learn. So whatever you're building architectures, try to limit it to 5 logos. Try to limit it to, it's not a hard rule, but you reuse as much stuff as you need. Remember, if you have 10 people in a project, that's it. Those are your specialists. If you don't want to be bogged down by other teams in your organization, by political crap because you don't have the knowledge that you need, or because simply you just happen to have 10 people in your company, that's it. So make sure to reuse as much as you can. Cool. Again, like we look at data and we start seeing the things that we can do with data, and it's very easy to start thinking, hey, let's have everything. Let's have all the bells and whistles. Let's have all the features. And I know I'm preaching to the choir here, but I've seen this over and over again with really, really senior engineers. And that's because this is new. This is super exciting. And like your product owners or your CEOs are going to be asking for this all the time. Hey, can we do recommendations? Can we do chatbots? Can we do dynamic filtering? Can we do like all that cool stuff? Yeah, absolutely. But get it done one at a time. Just get it done. Execute. Don't try to come up with the perfect design that is going to take forever to get out there. Just get it done. Last but not least, if you get a lot of people, a lot of intelligent people in the same room, and you're dealing with something as exciting as data activation, and as new to many people as data, there are bound to be many arguments. There are bound to be many conflicts. Always remember that people are the most important thing in your organizations. Never lose track of that. So when you're getting like that super important data project out there, when you have to move your MVP forward because you're running out of funding or whatever, like remember that the people that you're working with, those 10 people that are in your teams, like that's it, and you'll be working with them tomorrow. So whatever you do, just remember that. Cool? And that's it.